Hello everyone, I am Sujata Singh, Faculty of Chemistry. I welcome you all to the official YouTube channel of SRN International School. In this video, I am going to discuss the topic Chemical Kinetics for Grade 12. Chemical Kinetics. Chemical kinetics is a branch of chemistry that deals with the study of rates of reaction and their mechanisms. Some reactions occur very fast, like ionic reaction. For example, precipitation of silver chloride, which occurs instantaneously by mixing the aqueous solution of silver nitrate and sodium chloride. Some reactions are very slow, for example, rusting of iron, and some proceed with a moderate speed, for example, hydrolysis of starch, inversion of cane sugar, and so on. The word kinetics is derived from a Greek word, kinesis, which means movement. Rate of a reaction. Rate of a reaction is defined as change in concentration of a reactant or product in unit time. That means when reaction starts, then there is a decrease in concentration of a reactant with time as well as increase in concentration of a product with time. It can be expressed in terms of rate of decrease in concentration of any one of the reactants as well as rate of increase in concentration of any one of the products. Average rate of a reaction. Consider a hypothetical reaction like reactant converting to product. That is, R is a reactant and P is a product. So when the reactants like hydrogen and iodine react together, they form a product that is hydrogen iodide. So for such reactions, when we take R as a reactant and P as a product, then rate of a reaction is equal to minus delta concentration R upon delta T, which is equal to delta concentration P upon delta T. Here, the square brackets used in this given expression expresses molar concentration. That means concentration in terms of molarity. So it will be negative for the reactant and it will be positive for the product, because in case of reactant the change in concentration is given as C2 minus C1, and since C2 is less than C1, so then the value will come out to be negative, and to make the rate as positive we make it negative in front of the concentration of the reactant. So therefore rate of a reaction is given as minus delta concentration R upon delta T, and rate of reaction is also equal to concentration of, that is delta concentration P upon delta T. Units for a rate of reaction is given as mole per liter per second for the reactions occurring in solutions and atmosphere per second for the gaseous reactions. Instantaneous rate of a reaction is obtained when we consider average rate of a reaction at the smallest time interval, that is dt, which means that delta t when approaches 0. So mathematically, for infinitesimally small time interval, that is dt, the instantaneous rate of a reaction is given as rate of a reaction equals to minus d concentration R upon dt, which is equal to d concentration product upon dt. So it can be determined graphically by drawing a tangent at time t and calculating its slope. Factors influencing rate of reaction. The rate of a reaction depends upon various experimental conditions like temperature, pressure, catalyst, and concentration. So when these factors changes, then what is the effect seen in the rate of reaction? For example, when temperature is increased, the rate of a reaction also increases, and rate constant also increases. When the pressure is increased, then there is a increase in the rate of a gaseous reaction, but the rate constant remains same. It doesn't change. When the concentration is increased, then rate of a reaction also increases provided the species included in rate expression. And rate constant does not change. When the catalyst is added, then there is an increase in rate of a reaction if catalyst is designed to increase the rate of a reaction. And rate constant also increases. So as we can see in the graph shown there, when energy is plotted against the progress of a reaction, then reactant will only convert to product when some activation energy is supplied. Now the reactant has its own energy, and when activation energy is supplied to it, it converts into product, and product has its own energy. So difference of the energy of reactants and products is called as heat of reaction, that is given by delta H. And this heat of reaction can be exothermic or endothermic depending upon the difference of energy of the reactant and products. And one more figure is shown here where this metal surface is acting as a catalyst. For example, reaction of ethene and hydrogen gas, both are gases. Ethene is also gas and hydrogen is also a gas. So when they are reacted together in presence of a catalyst like metal, palladium, platinum, nickel, then it converts into ethane. Ethane is a product formed. And this catalyst uh, increases the rate of reaction. It makes the reaction faster. So when here the metal surface, that is the platinum, uh, on this platinum, hydrogen gas and ethene gas, they form a bond. And then they collide with each other and convert into product, ethane. And then it detaches away or get dissolved or gets away from the metal surface. So this is how a catalyst increases the rate of a reaction. Rate expression, also known as rate law or rate equation. Rate of a reaction is represented in terms of concentration of reactants, and then it is called as rate expression or rate law expression or rate equation. Consider a general equation, a reaction like A plus B forming C plus D, where capital A, B are the reactants and capital C, D are the products. Small letters A, B, C, D are the stoichiometric coefficients respectively. So rate of a reaction is directly proportional to the product of the concentration of the reactants A and B, each raised to the power X and Y. Rate is equal to K, concentration of A raised to the power X, and concentration of B raised to the power Y. So exponents X and Y are the orders with respect to the reactants A and B. And K is the constant of proportionality called as rate constant. Rate constant is defined as a rate of a reaction when the concentration of reactants is taken as unity. Rate laws for elementary reaction. Rate law for an elementary reaction will follow directly from its molecularity because elementary reaction is an individual molecular event. That means elementary reactions are one-step reaction. So the rate laws for these elementary reactions will get from its molecularity only. Like for unimolecular reaction, rate will be given as equal to K, concentration of the ozone O3. For bimolecular reaction, rate will be equal to K, concentration of O3 into concentration of O. And termolecular reaction, rate will be equal to K, concentration of O to the power 2 because there are 2 into concentration of M. So therefore the rate law expressions for these elementary reactions will get it directly from its molecularity. Units of rate constant. From the rate expression, we can find out the units of rate constant for zero order, first order, and second order reaction. So after derivation, with different orders of the reaction, we can obtain the units of rate constant as follows. For zero order, reaction, the units of rate constant is found to be mole per decimeter cubed per second. For first order reaction, units of rate constant is found to be per second, and for second order reaction, it is per mole decimeter cubed per second. Molecularity and order of a reaction. Molecularity of a reaction is the number of molecules which collides simultaneously to form the product. An order of a reaction is the sum of the powers of the concentration of the reactants in the rate law expression. So there is a difference between molecularity and order. Like molecularity is a theoretical concept, whereas order is an experimental concept. That is, it can be determined experimentally. Molecularity has integral values only, whereas order can have fractional values also. Molecularity cannot be zero, but order of a reaction can be zero. Molecularity provides no information on reaction mechanism, whereas order can tell us about the reaction mechanism, because in a reaction, when it happens in various steps, then the slowest step in the reaction is called as rate determining step, and it can be judged by the order of the reaction, and this gives further information about the mechanism. Thank you for watching this video. Please like, share and subscribe our YouTube channel.